What I'm going to do is plot a scatter graph using the information that I've got in the table. Right, I've got time along the x-axis, along the corridor. That's time, amount of time revising, and number of mistakes. I've got 6 people that I've sampled. First person, you can see here, has revised for 10 minutes and has 14 mistakes. Right. Second person, 15 minutes of revision with 11 mistakes. Right, find the 11 up the stairs, that's between 10 and 12. And you do the same thing for all the other values. Right, you just make sure you got the values the right way around. You know, you don't want to do 11 along the corridor, 15 up the stairs. Just make sure you got time along the corridor and mistakes up the stairs. The last one, 15 on the corridor, 3 up the stairs. Right, sometimes you might get values that are way out there, right? It's what we call, they're not mistakes, but what we call anomalies, or you can call them outliers. In this case, we don't have any. What you then need to do is draw a line of best fit using a ruler. A line of best fit would have roughly the same number of crosses on either side of the line. Right, your line of best fit and my line of best fit are going to be different, slightly different. No two line of best fit are ever going to be the same. It does not matter if line of best fit goes through 1 or 2 crosses. So you get a ruler, you can make sure you've got a see-through ruler. So when you draw the line of best fit, or where you intend to draw the line of best fit, you can see roughly the same number of crosses on either side of that line. So I'm going to place my line of best fit roughly there. You make sure you start the line from where the first cross happens. You don't draw the line of best fit beyond the first and the last cross, because we don't have enough information there. So there's nothing there, and there's nothing over here. That's why I've not extended the line of best fit. Right, a pupil revised for 25 minutes. Now, we don't have that information here for the 25 minutes, how many mistakes. Use the line of best fit to estimate the number of mistakes you'd expect a person with 25 minutes of revision. So what you do is you can use the line of best fit to get the information. It's what we call interpolation. Interpolation, because that information, that 25 minutes, is within the data that we have. Draw a line, find 25 minutes, draw a line. When you hit the line of best fit, turn left. Right, it looks like we've got a decimal value, but because mistakes are whole numbers, you could say that's 9. You could say that's 9 mistakes. So somebody who makes, somebody revises for 25 minutes, you'd expect that person to make 9 mistakes. Now, what you can't do is use that line of best fit to find information about, let's say, when somebody makes 0, when somebody revises for 0 minutes. There's 0, but if you go all the way to the top, you know the line of best fit doesn't extend there. So we can't use that line of best fit that we've got at the moment the way it is. And for the same reason, we cannot find, for example, how many mistakes a person is likely to make if they've revised for 55 minutes, because the line of best fit is not there. But there's a way around it. Is what you can do is extend the line of best fit. So you can do it like a dashed line. You know, you can call that a ghost line of best fit if you want. And then, for example, if you want to know how many mistakes a person makes who's done 55 minutes of revision, that's roughly 1. So what we've done is extrapolation, not interpolation. We've extrapolated that information. And same for the 0. For 0 minutes of revision, you'd expect that person, if it's 0 minutes, you expect that person hit the line of best fit right there, 16 mistakes. So somebody who's done no revision, you'd expect 16 mistakes. So that's extrapolation that we've just done.